I'm honored to introduce and invite on stage our moderator for this session, Dr. Ramaraju Poosapati, Senior Manager at Capgemini. Ladies and gentlemen, let us hear it loud for Dr. Ramaraju. His expertise in the field of AI makes him the perfect guide for our conversations today. Let's welcome him with a huge round of applause. I'd also like to invite our distinguished speaker, Mr. Laxmi Kumar Reddy, Executive Director, AI, JP Morgan Chase & Company. Mr. Reddy's vast experience and insights are sure to enlighten and inspire us as we navigate through the complexities of generative AI and LLMs. I would now like to hand over to Dr. Ramaraju to lead us through this discussion.
Good morning. Namaste, Vishakhapatnam. I am Laxmi Kumar Sammeta. I am an Executive Director with JP Morgan Chase. Currently, I am leading AI and ML platform, which is a centralized AI and ML platform for entire JP Morgan as a firm. So, data scientists across JP Morgan firm would come and kind of train their models, serve their models. Also try to kind of do the model modeling on top of the platform that we build. With that, I'll just get started. So my topic today is generative AI, which is a lot of, which is being spoken a lot. I know there is a lot of fluff, a lot of buzz around it. So today we'll try to kind of cut through the fluff and see the practical sense and applicability of this. I'm going to go little sparse, not too deep tech, right? To kind of catch what I calls. I see a lot of young folks, in terms of academias and others. So I'm here to kind of ignite some interest and show the avenues that Gen AI as a technology can present. We'll also discuss some of the challenges, right? And potential harmful avenues that as a technology Gen AI is there to present us. So with that we'll get started. Though I'm from JP Morgan, the kind of opinions that I'm sharing or the knowledge I'm trying to present are not official stance or opinions of JP Morgan. I'm here to kind of take you past my experience with the technology, right? So I have 15 minutes to talk through, and then I'll go sit with Rama to kind of go through his questions as well. So let's get started with this quote, right? Just when we thought software was eating the world, now generative AI is eating the software. So I wanted to show this to give you a sense of how emergent this technology is, how rapidly the landscape is kind of moving. Certainly, undeniably, this is unprecedented software disruption that we experienced, at least in my experience, right? So we are seeing it's very transformative in the sense it is actually making a lot of impact on the industries. It is trying to reshape the way the traditional business model work, right? So not just there, it is also trying to show a lot of positive impact on the innovation side and the creativity. In terms of prototyping, you can leverage it to kind of quickly and rapidly prototype something, and in automation areas as well, right? So what is generative AI? This is a textbook definition, right? So Gen AI is a subset of AI again, and that creates the content based on the data set of previous examples. So the difference of Gen AI is, earlier traditionally you give an input and AI or a model is going to choose or classify and give you the output, which is again a part of the input that you have given. So Gen AI is more creative. It's going to kind of give you a new output. It's going to write something new based on the examples that it got trained with, right? The LLM, again, this is like any other model, right? Which learns and generates like a human, like language using transformer architecture. So how do they intersect, right? So in the text generation, for example, Gen AI, I think it already had this generative adversarial networks, GANs, and LLMs transformer architecture. So combinatorially, both bring in a lot of value to give you the sweet spot of leading a lot of innovation in the areas that we never thought it can show the impact on. We're going to look into a couple of areas that it can really have the impact. We're going to touch base on the spectrum of avenues that Gen AI as a technology is going to kind of help us, right? So if you have a Gen AI, what do you have, right? You have Einstein in your basement, right? Einstein, when I say Einstein, he is sum total of intelligence of smart people who walked on the planet, right? Now you have access to this guy, you can talk to him anytime, he never loses the patience, right? And he can answer anything without losing the patience. That's the specialty, that's the analogy that I would like to bring in to really exemplify the benefit of this technology. Now, what can it do? I think all of you know this. It can it can basically consume a lot of massive amount of data sets of various modalities, like be it data, voice, kind of 3D signals, images, and so on and so forth. Now you have center of the picture, the LLM. Let us treat for now the LLM as a black box. We don't know anything about it, right? So that's a model which can basically consume. It got trained on different sets of data from different modalities, and then let's see what it can do, right? It can do information extraction, instruction following, object recognition, image captioning, Q&A, summarization, and sentiment analysis, right? These are a couple of avenues that we can read out from internet as an offering, right, of this technology. But if you really look at kind of combinatorially, for example, you're trying to solve a problem in autonomous systems, so you have to enable your vehicle with a lot of decision making capabilities, and it may also require to recognize an object, right, which is object recognition. So combining both of them, you are going to take your autonomous systems building to the really next level, right? Or if you have a LLM model, a foundation model which you bought from kind of open AIs of the world, and you would customize that with your medical data, so that's going to help you in drug discovery or planning treatment for a kind of patient or medical diagnosis, right? In financial, the avenues are limitless. Basically, I mean that's why the finance is the top domain today, which is adopting Gen AI like never before. I guess finance was always averse to kind of welcome the new technologies by far. It just got started like 5 years ago with the AIs and MLs, but Gen AI right from the outset, it found the value in the technology, and then it started adopting into various use cases. Some of the avenues that I can call out essentially is, if you are trying to invest something, you can actually look at how your fund can grow, look at the trajectory. You can build a lot of risk models, right? And it can help you analyze the market trends and so on and so forth. So these are a couple of avenues that I want really people to look at, instead of just looking at the capabilities as the outcomes of this technology. Now let's see. I'm sure as the technicians, we all would worry about how do I kind of productionalize these LLMs, right? This is little being far from being a real technology for a lot of enterprises today. So I'm going to get into a little one down layer of showing how you can really bring in the technology to the full stack development that you do on your day to day, right? So you have state-of-art foundational LLMs provided by, say, OpenAIs of the world and so on and so forth. You kind of bring in. So this white piece of, the picture says, okay, this is trained with a massive amount of data, public data. It knows a lot, right? He's an Einstein. And then you have proprietary data of your domain, right? So be it medical, finance, or whatever. And then, as usual, you're going to clean the data, label data, kind of build the data pipelines, apply all ethical, all, and then you kind of embed them into vector space. And now, essentially, what you're going to do here is you're bringing the generalized model, and you're also customizing so that this model as a whole can help your business, right? And then this is obvious, you expose the API, and then you have your own digital channels like mobile applications and user applications, etc. User starts using, right? And the beauty of this technology is this model is a continuous learner. Essentially, it can learn a lot from the human feedback. That's what we call it as reinforcement learning from human feedback, RLHF, right? And on top of that, essentially the couple of things that we need to be keeping in our mind is, we need to, this is not a one and done sort of process, it is a continuous thing, right? So you'll always have to have the active model monitoring, which is a continuous process that needs to happen. And you need to collect the metrics on accuracy drifts and loss function drifts and so on and so forth, and then keep doing the fine tuning accordingly. So this is like a continuous training of the data of the model, right? So with this, we in the enterprises can easily enable NLU capabilities in your full stack. This technology cannot be by itself. It can help your applications to increase, your user footprints, like enabling a semantic search, like a Google, right? You can enable a Google kind of capability within your application as well, and so on and so forth, right? There are some challenges which I'm going to talk about in a bit. If you look at the LLM landscape today, you can't see my cursor, but if you look at the top left box, right, these are the foundation models and hubs today. OpenAIs of the world, AI-21s and Googles, they are the market players today. They are giving us the state-of-art LLM foundation models. There are open source LLM models as well, like Blooms and Whisper. We can basically bring in them kind of having your own private GPU instance, and then start learning and fine-tuning that as well to meet your needs. And there are some LLM models which are very specific to code generation, right? Codex and code. So these are ultimately and real sophisticated code generation tool. I would recommend the N-Shops because I think this technology is going to reshape the way you're going to write the code. You are not going to write the code the way you're writing today with the advent of this technology. You have to kind of step in, leverage the code generation, LLMs, and then start pushing your product off the ground, right? And then there are some LLM development models as well, like LangChains and so on and so forth. Combination of these technology led to already you are seeing a blooming spray of applications spanning across the spectrum, be it writing assistants or content generation domain, or kind of in the semantic search side of things. Also in the data specific domains like data extraction and cleaning, and into the coding as well. So you see the set of applications which made to the market, and they are successful today, right? By the time we understand some technology, I think there are already applications which put the technology to the practice, and they're making money out of it, right? So you have a lot of tools and foundation models. For you to pick, this is always a paradox of choice analysis. You have open source, closed source, and how do you pick this, right? Some of the points that I would like to talk about is you will have to be very certain about the latency, the performance goals of yourself, and the quality of the output. Essentially, we are going to worry about two things, accuracy and performance in this domain. So based on your tolerance levels, you can pick and choose between open source and closed source, right? And also there is a way for you to kind of chain the models in such a way, okay, if there is a prompt coming in, there is a input from the user coming in, which you don't need a lot of accuracy for, then you can actually route this request for less premium model. But if you are depending on the response where you are going to make a decision making, you want a very informed decision kind of provided by your LLM, then you would route that request to your premium model, right? So you'll put that intermediate orchestration layer in between, and you would kind of do this routing so that you can optimize on your cost as well, right? But there is a question: how do you? Why do you want to depend on the foundation models? What takes to really build your own model, right? If I'm going to build the foundation model myself and target for say 50 billion parameters training, do you guys guess how much does it cost approximately? 10 billion, right? Not less than that. It is small sum of 10 billion at minimal, and that is only the training cost I'm talking about. It's not even infrastructure, it's not even development, nothing else, just training cost. So it is that big. That's when people are trying to kind of leverage the existing foundation model, and they specialize them in their own domains so that it can be put for their business use cases. All right. Now the other, so here is the thing by Gartner. Gartner is trying to kind of forecast the impact and kind of activities that Gen AI can present in the future. In 2024, I think we are struggling with the synthetic data generation to kind of train our models in the lower environments. So 50% of that activity is going to be taken over by 2024. 2025, 30% of outbound marketing messages will be automated by Gen AI. 2026, this is a kind of alarming red flag. If you look at the second point, over 100 million human will engage in robo-colleagues to contribute to enterprise work, which is going to kind of displacement of some of the jobs, right? We'll talk about this in a bit in my interview with Rama. And 2027, this is interesting, nearly 50% of new applications will be generated by UI. Where we stand today, we are zero, right? So this is the emergence that Gartner, this is not my projection, this is Gartner's projection on the technology and the impact that it can bring in, right? So before I kind of go to my panel interview with Rama, I want to present this, right? Life is incomplete with a laugher, and laughter is incomplete with a meme, right? Look at this. This is, I think, insightful meme. I really love this. This meme is going around for some time. So you guys can read this, or you want my voice over that? You can, right? So a person like me is struggling to kind of learn and catch up with this technology. In the second picture, it says, oh boy, RNN, CNN, tokenization, transformers. This is going to be a long day. Third day says parameters, attention mechanism, positional encoding, I need a break. And then he gets into aha moment. This is a light bulb moment. He says, I've got it. I use LLMs to explain LLMs to me, right? So this is the best way to learn LLMs, and for that matter, any technology. And that's the LLM uniqueness, and it has got a lot of things in store for us. Which I think I'm going to surface a few more things in my interview with Rama. Thank you so much.
Good morning, everyone. Okay, In the interest of time, we'll take very little questions. So we'll squeeze the time that was given to us. So you talked about transformer models. I think AI has evolved more than 2 decades, 3 decades. It took a lot of years for AI to develop. But in 2017, after this Attention is All You Need paper, which got published by Vaswan from Google Brain, it has come up, like all Gen AI technologies have come up after that, using the transformer models. So what do you think are the future of this future of these LLM models, and how we can use this for a benefit to enhance the existing performance of these models?
Can you hear me? All right. So I intentionally did not really tell a lot into the technology aspect of. So I intentionally omitted some of the details so that we can cover a part of this interview. So on the transformer model, I guess this is not a new invention. There have been a lot of efforts and neural network architectures that were put out. For example, CNNs and long short term memory, right? LSTMs, the world. But none of them really achieved the 2 goals that I quoted. So out of the LLM, you want accuracy for sure. There is a smaller portion of hallucinations, etc., as outputs from the LLMs today, but then you need the accuracy to the acceptable level as the predictions out of this model. The number 2 aspect that we really look out for is the performance, right? We need to really get glued with the user. You need a microsecond performance, though you're mining a lot of data in the background. So the models earlier never focused or never achieved the goal of performance. So transformer basically brought in something called attention. It's a simple English, right? What is attention? This is nothing but a focus, right? Where you want to prioritize, where you want to give importance to. So I'll just bring in a simple example. All of us read the stories, right? We have memory, we have brain. Assume we have analogy-wise, that's a neural network, right? So you go through the story, you remember the events. Now you also remember the roles, key players of the story, and you also build the relationships between each of the actors in the story, right? Only then it makes sense. Now you read half the story, and you thought there is a role which is supposed to be very positive role, but basically is evolving into a bit of a kind of non so positive activity, right? But do you really suspect? You don't suspect, because his history was never been. He's the main. For example, he's a hero, right? He do a lot of things, both positive and kind of negative. But you give that. There is a method in the madness, right? So similarly, you are going to train the model on the words, the connections between the words, and the depth and non-linearity sort of technologies. So I'll just explain, right? So transformer has principally two sections, right? One, encoder and decoder. So encoder has a series of levels of attention layers, self-attention layers, and then each of the input that you give to transformer has to pass through all the layers basically, right? So first layer, it brings in, so it reads the word, it tries to kind of convert all of them into something called as hidden representation. Now next level, it tries to identify the word with the semantics. So your representation gets matured to semantic representation. Now it brings in the dependencies between the words, right? Though they are placed very away, or it doesn't matter, but it applies that some contextual algorithms to figure out the context aware representation. So you saw the hidden representation now became semantic, now became context aware. So it became mature. So you have that the representation which is ready to consume by decoder. Now decoder also will go through a lot of layers of self-attention. It also applies the cross-attention as well, which we also call as multi-head attention, which was not the case in other types of the models. That is the aspect, right? That is the aspect that is differentiating the transformer architecture with something else, because it is actually very time performant and so on. So overall, the input that you are going to give is a sentence. It can basically consume it, but the output is always spit out of one word. So if you go and kind of do the chat GPT, it always gives you word by word. Right?
In short, it helps us to overcome the problem of contextualization, which was not there earlier.
Exactly.
Right.
So
Right.
it, as you go through the layers, basically it starts giving you more context to the sentence.
Right.
Yeah.
And you talked about the cost that is involved in building an LLM models.
Right.
But anybody of us can fine tune an LLM model and can use it. So what are the different challenges that we might have to face while fine tuning a model and using it for our own purpose?
Yeah, so fine tuning again is a very domain specific. One of the callouts that I have for fine tuning is you need to have a very high quality data which you trust first of all as a business, and which should be a representative data as well, right? You have done the thorough validation of the data, you have labeled it, you cleaned it, it went through all the governance vetting, and then you start training the model with that data, right? So having the high quality representative data is one challenge, because without that your model cannot be expected to really perform well. So the other challenge that we have is, I think data set is never a stale or static thing. It will keep changing, right? So there is a challenge today with the data sets shift basically. So once you train the model, it's not one and done. You would have to continuously monitor, keep looking at the data that got changed, and then start feeding that data to the model as well. That's one other kind of challenge with the fine tuning. I think these are the two callouts, Rama, that I would like to bring on.
Coming back to deploying this model, fine tuning and deploying this model. I say I am a startup company. I wanted to fine tune a model and incorporate some legal data, as Sir was mentioning in his keynote speech. So I wanted to build something as a legal GPT kind of a thing. I wanted to build that. So I took an LLM model, fine tuned with the domain data on legal aspects, and I have created it.
Mm-hmm.
Now, as a startup company, how do I ensure that I commercialize this in a right way and use this in a right way? What methods do I need to follow to ensure that I commercialize my model in a better way, rather than being taken away by somebody else?
Right. So one of the similarity or commonality between the startup and technology is both are agile and speed, right? They don't really carry a lot of baggage. They're swift to catch up with the technology and start moving fast. So I think the LLM space also is an apt, domain for startups to adopt. The biggest challenge is with the limited resources that startups have, having the data which is high quality again and representative data available for their market is a problem, right? It's very expensive, and they cannot fine tune the data for a general purposes. That's a problem, right? So they like to target the domain and then get that relevant data, start training this, and then push it out as a product off the ground, right? That's the biggest challenge. And then of course they will have to navigate through a lot of ethical and transparency side of things as well, which is not easy for startup to kind of formulate a lot of frameworks or anything around this, right? They need a lot of talent which is specialized in ethical and transparent and compliance side of things. Only then they can build the teams like this. The commercialization aspect, right? They can accelerate. First of all, I think they need to have the strategy, whether they're trying to push this as a SaaS offering, or they want to enable this as one of the integratable component, which can basically be integrated by a large enterprise. But what I would like to conclude this thing with is, startups cannot alone thrive and see the success in silos. Basically, they need to tap into bigger markets. They need to partner and collaborate with the larger organizations. Only then they have the access to the bigger business that large organization already owns, right? I think this is a good combination and sweet spot for large organizations also to kind of welcome the startups because they build the applications fast and I have the data, right? This is combinatorially, this is a good combination.
One or two questions from the audience in case if you have, or else we'll conclude after one more question from my side. Any questions? L0, L1 jobs being taken away. Like we have seen a lot of automation happening in the low-end jobs that we are seeing. So in this scenario, what the young generation, the students, have to think in mind or have to adopt just to ensure that their career is successful going ahead with the advent of Gen AI technologies.
Yeah, this is fact, this is real. With the emergence of Gen AI, there is a constant fear in the tech circles and outside that this is going to create a displacement of a lot of disciplines that IT currently runs with, right? Which is good and bad. So I think all the mundane, jobs, I think we have seen testers in 20 years ago, 10 years ago, they are no more dinosaurs, right? This is a continuous kind of, I would say, this is how industry evolved. But it has challenge. It's going to throw the challenge. It's going to kind of make some of the roles kind of becoming dinosaurs. There's no doubt about it. But it also is going to bring in a lot of opportunities and avenues for the new disciplines. So, Sir was explaining in his speech, right, which was really insightful, that Gen AI as a technology is something which is going to invite interdisciplinary roles into it. So this has a lot of scope to invite lawyers because they know the law, right? They are the specialists in that domain because they need to collaborate with the software teams to say what is right and what is not in terms of copyrights, in terms of anything. Also, this is going to create new opportunities for the psychologists, which we never had an opportunity to work with as an industry, because this is all about creating a nice interaction between AI and a human. There should be a middle layer between, right? I guess many more, right? Ethical side of things. We are going to be needing a lot of ethical specialists as well to complement our development. So I think this is going to invite an array of new disciplines which were never part of IT development by far, and which is a positive development in my view. So let's have that optimism and positivity to really see this technology coming and kind of reshaping the way we work.
That was great insights from you. Rest of time we'll stop here and in further questions we'll take offline.
Absolutely. Fantastic. Thank you so much, folks. Thank you.
Mr. Ramaraju Poosapati and Mr. Laxmi Kumar Reddy for their enlightening discussion and invaluable insights. I would like to extend an invitation to Mr. Anand to present a token of appreciation to our esteemed speakers. Mr. Laxmi Kumar Reddy